Main Street and the Southside area is becoming one of the more thriving districts in our community. It involves what you would think of as any standard of livable community in our nation. It includes now amenities and living situations where you can walk or bike to work, or walk to transit, or bike to transit, and get to pretty much anywhere in our community. And the Clearstory project really fits into that, and what we believe is a very sustainable approach, that reusing buildings for a second life and reusing buildings on the existing footprint with in the existing city grid with all the infrastructure available to reuse is the most sustainable approach that we could take. Within walking distance of this area, for LEED requirements, we established 10 amenities that could be available to residents, and that allows us to achieve one of those credits. We also achieved a pretty intense approach to looking at urbanism for location to transit routes and our density, our community density. This is a model project for how to reuse our urban footprint, our inherited footprint, and our buildings that are really underutilized. Our challenge with Clearstory is the renovation of a structure that was designed for a different purpose, and we're repurposing that and using it to inhabit it in a different way.
Our goal with this building, for sustainable building, is to have a building that basically does not need to be connected to the power grid. We would be connected to it because there are certain times that we'll be using power, at other times we will not. But it allows us to basically, we're shooting for a zero electric bill, which reduces the carbon footprint of this area and the requirements for this building.
It was a challenge to approach energy and energy consumption as far as an envelope goes for a building that really wasn't designed to be as tight as we wanted it to be.
The process of having the contractors and the architect on board very early in the process is you can't measure how valuable that is. The contractors have a good feel for what is practical to install and have a good ratio of cost to what you're getting as your end result of your cost. We can design anything, and I can design controls that will do a lot of different things, but if they're not practical to install, and from a contract point of view and a cost point of view, they're not really valid to the project. It allows us to talk, sometimes scratch our head and beat our head up against the wall on what is the best approach for the end result for the customer.
We spent an intensive amount of time looking at how to drive the energy demand for the building down as far as we could get it to zero. A typical building of this magnitude would take, for instance, a 50 to 60 ton energy demand for heating and cooling, and we drove that down by half, looking at it and doing that in a responsible way and trying to do it within a budget that works for a market rate project is very challenging.
The LEED process is great from an engineering perspective. It allows us to sit down with the owner, the contractor, the developer if there is one, and the architect, and go through all aspects of the project. Being an engineer, we try to do things to the owner's satisfaction, but at the same time achieving the best energy value for your dollar. And it allows us to all work together intimately from the beginning all the way through the design and the construction aspect.
Some of the challenges, especially with a building like this and keeping in with the LEED goals, is some of the like the demolition debris. There's a large amount of debris that was going to be generated from the creation of the courtyard, and taking a look at the tonnage used and the way we were going to modify the parking lot, and possibly the use of that debris, of that ground up brick and concrete and those things for the infill of the parking lot. One of the biggest goals in any project like this, it's going to be LEED certified and is a major renovation, is what do you do with all the debris? Because the more you divert from the landfill, the better off you are.
We chose as a goal to target LEED for new construction, version 2.2. And with that, we established an early checklist through a charrette process where we identified about 47 points in the checklist for LEED for new construction that we could attain as parts of our project. Some of the most progressive that you'll see in sustainable sites, for instance, we looked at the opportunity to pave the parking with open grid paving and use a gravel system that allows most of the water filtration to happen back to the aquifer, which is a very innovative approach for LEED for new construction. We chose to occupy one of our roofs, one entire roof with a green roof system, and make that available as an amenity. And that also deals with water quality issues and water quantity issues on our site, reduces the demand and reduces the impact on our stormwater system for our city. We looked at a geothermal system, which is an incredible benefit to our overall energy demand.
This building is designed based upon a geothermal water source system, and that allows us to dig. I believe we're currently at 9 wells in the ground that will be taking heat from the ground, or we'll be extracting heat back into the ground to end up cooling and heating the building through the air conditioning units we have located scattered throughout the building. At the same time, we're able to take the heat that is being produced and heat the hot water system, and we have a redundant backup system using a water-to-water heat pump system. So it allows us to basically provide domestic hot water for free to the building using the air conditioning system as a means for heating that water.
The budgeting and the evaluation of different systems and different designs and the upfront design of the building is a great end benefit to the owner. And what we have found, and what the Strauss Company really has excelled at in the last few years, is getting in with projects from the very start and on the design phase, and doing a lot of budgeting. And so when we, instead of an engineer or an architect seeing a goal of a certain R value or something, and just picking a design or picking a certain product that'll achieve that, what we're able to do is we're able to take those ideas and such for obtaining a goal and budget them, and say, okay, well, this is, and then offer alternate ideas, for what they want to do. And shading is one of them. Obviously, we went through several different scenarios of how to properly shade the building, working with the engineer, knowing what the end goal is, and working with the architect and knowing what the design goal is. He was able to tell us what he wanted, basically the end effect to be as far as appearance and aesthetics and flow and those type of things. And the engineer was able to tell us what we needed to do to reduce the solar gain, or up the energy efficiency of the lighting system or whatever. And obviously they had ideas to throw out as to how to meet that goal. And we were able to take several ideas and then offer to the owner different options as far as what the net effect would be to the budget at the end. Because in the end of the day, what you've got, 3 major things you've got to do. You want to be LEED certified, you want to be highly energy efficient, and you want to be fiscally responsible. It has to be a fiscally responsible project in order for it to move forward. So what we're able to do is to establish a baseline budget, given the certain goals parameter, and then to take all the different components that are needed to reach these goals, and throw out different budget numbers and say, okay, you can do this system for this much money, or this system for this much money, and here are the net effects. Then go back to the engineers, and they can tell us the effects that maybe the different options would have. And in many cases, some of the lesser expensive items would retain or increase the aesthetic value of the building and still produce the effects that the engineer needed in order to reach his energy efficiency level.